We are Team GelPure, an early-stage startup coming from Akron, Ohio, and we are developing solutions for the removal of PFAS from drinking water. These are synthetic molecules which are partially or majorly fluorinated along the length of the molecule, held together by strong carbon-fluorine bonds, which results in their lack of ability to degrade in the environment. They've been used for many applications, including nonstick cookware, water-repelling clothing and furniture, and firefighting foams. These chemicals build up in our blood and tissue and pretty much remain there for our lifetime, which increases our risks for various cancers and reduces our immune response. In 2024, the EPA regulated just 6 of these at ultra-low levels of parts per trillion, which is like a drop of water across 20 Olympic-sized pools. We're focusing on developing polymeric gels with high capacity for absorption, multiple rounds of use, and selectivity for PFAS. We want to make sure drinking water utilities remain compliant with EPA regulations, stay cost-effective so they don't burden their ratepayers, and be environmentally responsible. We have a lot of PFAS to clean up across the U.S., which has been in use since the 1950s. We estimate that the global market for advanced water treatment to be around $25 billion, which includes GAC, RO, and ion exchange. And specific to PFAS filtration for public drinking water, this narrows down to about $3.5 billion. And then further, provided we can capture a few percentage points of market share, we can project that we can make up to $100 million. Moving on to our competitive analysis, major competing technologies include activated carbon and ion exchange resins. The most obvious need is the ability to remove PFAS down to the regulated levels. Ion exchange resins and our materials can readily remove a variety of PFAS, but activated carbon generally struggles with shorter chains. Over time, this could require utilities to purchase even larger volumes of activated carbon. The second major concern that we hear about in our conversations with utilities is the disposal of spent absorbents. So activated carbon and resins are usually incinerated, and there's concerns about the emissions and therefore uncertainty about its continuation. We're proposing that we can regenerate the media more effectively and on-site using solvents which are acceptable to utilities. This is a roadmap of where we are and where we anticipate going. We have completed NSF's National I-Core program and VentureWell's E-Teams program, where we became convinced we have a strong business case, and we were awarded some other small funds such as Spark Fund and Synthe6. We're now looking to pitch and apply for SBIRs and partner with a utility to pilot. Moni and I are grad students in the Polymer Engineering program here at the University of Akron, along with our advisor, Dr. Jana, who is an expert of polymeric gels and porous materials. We also have the help of our industrial mentor, Dr. Carla McBain, who has the prior experience in scale-up of similar materials. PFAS-free is the way